All right, so we're going to continue our discussions about geometry. Specifically, we're going to look at some angle pairs today. And so there's some terms that I definitely want you to be aware of. So this lesson is going to be pretty heavy on the terms and the explanations. So supplementary angles are two or more angles that add up to 180. Okay, so we practiced this a little bit before, but if I called this angle 1 and this angle 2, notice that if I added these up, right, and I'm not really telling you what each of them is individually, although we could measure them with a protractor, right, but I'm telling you that that's 180 degrees from one side of the line to the other. Okay, so we would say angle 1 and angle 2 are supplementary. Remember that little less than sign is what we use to represent angle. Okay. By the way, supplementary angles don't have to be next to each other. These are called adjacent supplementary angles. Okay, adjacent means right next to. So they also could be separated. Okay, as long as they added up to 180, they would technically be supplementary anyway. And then the word that describes angles that add up to 90 degrees is complementary. And this is just two or more angles that add up to 90. So just like I am telling you for supplementary angles, these also don't have to be adjacent to each other, but if this were angle 3 and 4, okay, remember how we indicate that we want to say it's a right angle is usually with a box like that. So angle 3 and angle 4 would be complementary. Okay. So next we're going to look at a lot of different types of angles that occur when lines cross each other in certain ways. So the first one is vertical angles. Vertical angles is or are formed by two intersecting lines. Okay, they are angles that are across from each other. In a lot of text and websites, you'll see them called non-adjacent angles. Adjacent means next to, so they are not next to each other. And they're formed with any kind of intersecting lines. Okay, so if we numbered these angles 1, 2, 3, and 4, you just need to pick out the ones that are across from each other. So notice angles 1 and 3 are vertical to each other. And also 2 and 4. Okay. So in case you don't know this, the word congruent, okay, the symbol for congruent is the following. You do an equal sign with a little squiggly line above it. Okay, and congruent means has the same measure. And it turns out that no matter how they are drawn, as long as they're formed with intersecting lines, that vertical angles are always congruent. So if we look above, we would say that angle 1 is congruent to angle 3, and also angle 2 is congruent to angle 4. All right, so interestingly enough, you actually can tell a lot about angle measures based off of this rule alone. So I want you to draw the figure that I'm about to draw. And I would draw it in the order that I am. So draw two lines kind of straight up and down. Then draw a diagonal line. And then maybe form a triangle from that. And then what we're going to do is just label every angle we have. So it would probably be helpful if you labeled the angles in a similar fashion. In other words, I'm going to refer to these angles by their number, so you'll want your picture to sort of match up with mine. And I'm going to give you a few of these angles. So the measure of angle 2 is 70. The measure of angle 6 is 90. The measure of angle 12 is 110. And let's say that I said I wanted you to find all other angle measures using either some of the rules we just went over or something else you might have learned before. So I'm going to use a different color here, but let's label the angles that we know. Angle 2 is 70. Angle 6 is 90. And angle 12 is 110. Okay, I'm not putting the degree symbol, but technically these are supposed to have the degree symbol. It's just hard to kind of squeeze them in. All right, so let's see if we can figure out what all the rest of the angles are. In other words, I want you to tell me what the measure of angle 1, we already know angle 2, 3, 4, 5, we already know 6, 7, and then what about 8, 9, 10, and 11? Okay, notice we already know 12 also. So what I like to do is just figure out from my picture what's going on. Okay, so I'm going to start off with this angle. Okay, we want the angle that is opposite from this. Also notice that it has to be formed by two intersecting lines. So you're looking for like an X pattern. So notice this and this cross each other, which means 2 and 5 are vertical angles. So if 2 is 70 degrees, so is 5. Okay, but then notice 1 and 5 are supplementary to each other, right? They form a line between the two of them. So if we did 180 minus 70, we'd get 110. Notice we can't say that this is also 110, okay? Because actually it's not formed by an X pattern. It's not formed by two horizontal lines, okay? So maybe we need to move somewhere else. So let's take some other vertical angles. If this is 110, so is this. Well, that's going to make this 70 and this angle 970 as well. And then notice angle 6 is 90, which would make angle 8 also 90. So we can draw the little boxes there. And then I think we can get angle 4. Okay. Notice angle 4 would have to be, it forms a triangle, right? This is already 90 and 70 together is already 160, which means this is the rest of the 180 or 20. Okay, and now notice we can find this one, right? 70 and 20 together are 90, which means this over here had to also have been 90. Also notice that this 20, 90, and 70 add up to 180 as well. And then last but not least, angle 7 is just from here to here, okay? So it's just 180 degrees. So that's how I like to do a problem like this. I like to just label my picture and then just kind of fill in what I've got. So from just a few given statements, we can actually figure out a big picture like this using various forms of geometry rules that I know. Notice the rules that I used were that vertical angles were congruent, that angles that form a line between them or under them as their base are 180. Okay, and then also that angles, the three angles in a triangle have to be 180. Okay, so Let's go for some more definitions. Parallel lines, I think we all kind of know what those are already, but they are lines in the same plane that never intersect. So this was in your geometry glossary, I'm pretty sure. Okay, and how you show that lines are parallel in a picture format when you want to be clear is you use series of little triangles. So in other words, let's say I wanted to tell you that these lines were parallel. Okay, now they certainly look parallel, right? But we're not sure if they're perfectly parallel. Well, what you do is you put a set of triangles on them, and then this means parallel. Okay, or let's say we had two other lines that also seem to be parallel. We could show it in this way. So it's not just one set of triangles, it can be multiples. But notice they match up, right? Okay, so you can even have 3 triangles, 4 triangles, whatever. The important thing is you wouldn't want to label both of these with one triangle, because then you would be saying that all 4 of these were parallel to each other, when in fact just these 2 are parallel to each other, these 2 are parallel to each other, right, but not all 4 together. So you just match up the number of triangles. In other words, that's how you show parallel lines. Okay, so a transversal is going to be a line that somehow intersects another line. It's actually a pretty general definition. So if you had 2 lines that say looked like this, and then you had a line going through them both, this black line would be called a transversal for these other 2 because it's intersecting them. Okay. There's no requirement on how it intersects them, it just has to intersect them. Alright, so I wanted to get those terms out of the way because the angle pairs we're going to talk about next rely on us having parallel lines cut by a transversal. So I'm going to put a star by this, but if you have 2 parallel lines that are intersected by a transversal, so let's draw that. Let's draw 2 parallel lines. Okay, and remember, how are we going to show that those are parallel? Well, we're going to match them up as far as how many triangles we put on it. And then let's say that the transversal cuts through it in some way. And let's say that I started numbering the angles at the bottom. Which isn't the traditional way that I would number them, but I don't want you to get too used to how they are numbered. Alright, so I'm going to underline this if word. Okay, so if you have parallel lines cut by a transversal, then the following is true. So I'm going to say then ... because there's a lot of things we're about to say. Okay, and we're going to keep referring back to this picture here. So the first type of angle pairs that it occurs when we draw something like this, where we have parallel lines being cut by a transversal, is corresponding angles. So corresponding angles are where you have an angle pair where each is in the same location. Relative to each parallel line. So if we look at the picture above, okay, what I mean by the same location is angle 1 and angle 5 are both corresponding angles. Notice angle 1 is like the bottom right angle for this parallel line, and angle 5 is like the bottom right angle for the second parallel line. Okay, so angle 1 and 5. Okay, so which one would be in the same location with 2? Notice 2 is in the bottom right, so 6 is also bottom right, correct? If you're looking at the transversal or the parallel lines. So angle 2 and 6. Okay, what about 3? What would 3 be corresponding with? So pay attention to this group of 4, right? It's the top left, and so 7 would be the top left on the top. And then lastly, we have 4, right? And 4 and 8 would be corresponding. Okay, all of these are corresponding angle pairs. And just so you know, if you have parallel lines, that's why I underlined the if. If you have parallel lines, then these angles are congruent to each other always. Okay, that is not the case if the lines aren't parallel, okay, but as long as you know that they are, then these angle pairs will be congruent to each other. The second type of relationship that we will see is called alternate interior angles. Okay, so alternate interior angles are, first of all, it's an angle pair in the interior. That shouldn't surprise you because the name tells you that they are interior angles. So angle pair in the interior that are diagonally across the transversal from each other. Okay, so I'm not really able to show the picture on screen all the time, but I'm still referring back to this picture up here. Okay, so notice above, the interior angles are only 3, 4, 5, and 6. Those are the only ones on the inside. Okay, and notice angles 3 and 6 are diagonally across the transversal from each other, and also angle 4 and 5. Okay, these are all alternate interior angle pairs. Notice the name tells you, right? It's telling you to alternate sides, and it's telling you that they're on the interior. Okay, it turns out that if you have parallel lines, these are congruent as well. The third type of angle pair are alternate exterior. Now, I say I shouldn't really have to even give you a definition of this. If alternate interior meant that they alternate sides and they are interior angles, then alternate exterior angles are going to still alternate sides, right? But they're going to be exterior. So angle pair in the exterior that are diagonally across the transversal from each other. So if you look at our above picture, the only ones that are even exterior are 1, 2, 7, and 8, right? So the one that would be diagonally across from 1 would be 8. And the one that is diagonally across from 2 would be 7. Okay, and these are all alternate exterior pairs. And so once again, if you have parallel lines, these are congruent to each other also. All right, so the last type of angle pair is going to be different from the other three, just so you know. But they are called consecutive interior angles. Now, consecutive means one after another, right? Like if you have two consecutive numbers, they are one right after another. So consecutive angle pairs or interior angles is basically an angle pair. Again, it's going to be in the interior because the name implies that, right? But it's going to be angles in the interior that are on the same side of the transversal. So if you refer back to our picture again, notice they're actually going to be stacked on top of each other. So angle 3 and angle 5 are a consecutive interior pair, and then angle 4 and angle 6 are a consecutive interior angle pair. Okay, so all of these are consecutive interior. Notice we can't have any more because no more are going to be interior. The rule for these is different, so we're going to really accentuate that. But if you have parallel lines, these are not the same, but they do have a relationship. They're actually supplementary. So we got so used to saying angles were congruent to each other that I'm a little concerned that you'll think that they're all like that. Okay, so this is the one kind of deviation from that pattern. So rather than being equal, they are actually going to add up to 180. Okay, so I want you to draw this picture and I want you to fill in all angle measures. I'm going to give you just a couple of them. So the first thing I want you to do is draw two parallel lines separated by a little bit of distance. And again, we're going to say to everyone who might look at our picture, hey, these are parallel because we're using the symbols. And then I want you to draw a transversal this way. But then I also want you to draw a transversal going the other way. So if it's not obvious, a transversal is not unique. A transversal is any line at all that crosses through other lines. Okay, so notice we have two parallel lines in black, right? And then we have a green transversal and a red transversal. So I'm just going to give you a couple of angle measures and we're going to see if we can fill in all the rest of them based on that. So if I tell you this one's 65 degrees, and then I tell you this one is 70 degrees, you can actually fill in every single angle measure from that, okay, using the relationships that we just established, and maybe some others. Okay, so first let's talk about, these are vertical angles, right? So this would be 65 and this would be 70. But then can't we say that these are supplementary to each other? In other words, won't this have to be 115 since 115 plus 65 is 180? And then notice that's going to lock this in at 115 because vertical angle across from this one. What about this relationship? From here to here is 180, right? So if you take 180 minus 70, you get 110. So both of those would be 110. Okay, so then what do? Notice this is a triangle. So if we add 65 and 70, we get 135. And if you take that away from 180, that means this must have been a 45-degree angle. But since that is, so is this, because these are vertical angles to each other. And then notice you're kind of at a stopping point here. Okay, so here is where you have to incorporate some of our newer rules. You have to decide, first of all, what you want to call the transversal that you want to focus on, and then how to talk about what angles would be what. So I'm going to lay my pen over the transversal that I want to look at, or maybe something thinner. So let's say I want to focus on this being the transversal. Okay, so ignore the other line I have drawn. Okay, so notice this is top left corner, right? So what would be top left corner for this green colored pencil being my transversal? Wouldn't it be this one that I'm pointing at? So in other words, this is 65 because I chose to talk about corresponding angles. Okay, this was top left, this was top left. But then notice we can do everything else we did before, right? This adds up to 110, which means this must be 70. And then we can go vertically across from this one and this one. And then we're almost done, right? Here we'll get 110. Here we'll get 110. Here we'll get 115 and 115. And then lastly, I guess I could have done this one too. This would be 135, and so would this, because these have to add up to 180 as well. So notice I only gave you originally this angle and this angle, and from that we were able to determine what like 18 other angles were, okay, just based on our angle relationships. So I really want you to commit those terms to memory and kind of know what angle pairs are what. So I'd like you to pull out kind of the worksheets for this section and see if maybe you can work through some of these. So let's look at, I'm not going to do all of these with you, but one that would be a really great place for you to start would be this one. Okay, so this is where you're just going to learn what kind of angle pairs are what. Okay, so I'm going to run through these kind of quick. So angles 1 and 5. Notice I don't want you to memorize the numbers. It's the placement that I want you to pay attention to. Notice these are in the same location, so that means they're corresponding. Okay, 8 and 4 are also in the same location, right? Relative to the parallel line. This is bottom right. This is bottom right, so that's also corresponding. 2 and 7, notice they're both exterior, right? So 2 and 7 would be alternate exterior. And then so on and so forth, okay? 3 and 6 are on opposite sides, but both in the interior, so that's alternate interior. So again, do not memorize the numbers, it's the placement that's important. What do you notice about 6 and 4? They are both in the interior, but they are one after another. They are stacked, okay? So in other words, these are consecutive, okay? Notice it doesn't say consecutive interior, but it probably should. And then just so on and so forth, okay? So I want you to try to practice those. There's also another page that will help you, I think. Okay, so I want you to pause the video and take out this part of the worksheet packet and see if you could figure it out. And then after you pause the video, I'm going to project what the key should have been. The point of this exercise is for you to practice for you to practice naming the angle pairs. Let me find my key. Okay, so here's my key. I'm going to try to show the whole thing. Okay, again, try really, really hard not to memorize the numbers. That's not the point of this. So try to pay attention to the placement of all of them. Okay. Down here, let's look at number 12. I said those were adjacent angles because they are right next to each other, but they're also supplementary. Okay, so let me slide this down. 5 and 7 is what they're asking about. Notice these are just right next to each other and they form a line underneath them. So you could either say they were supplementary or adjacent. It's not that these actually mean the same thing. Adjacent just means next to, but in this case they're also supplementary as well. I just mean that both of those terms describe what those angles are. Okay. So you have some handouts that I want you to kind of try to look over. Sorry, I gotta get my papers settled here. Okay, so let's look at, and I gave you a lot more packets than we're gonna, or a lot more pages than we're gonna go through necessarily together, but so I want us to look at some problems where I ask you to do algebra a little bit. Okay, so this will help you kind of get ready for the homework that is attached to this. So let's say that this is what you're given. 2 parallel lines. Notice I'm telling you they're parallel by saying, hey, they have matching triangles. That means they're parallel. And then we're going to draw a line through them. Okay, remember this line is called a transversal because it crosses through the other two. And then let's say that I told you that this was x minus 24 degrees, and this was 2x plus 42 degrees. And I asked you to, let's say I asked you to find x. Okay, so the first thing you need to be able to determine is you need to determine what kind of angles these are. Okay, so these are consecutive interior angles, right? They're on the same side of the transversal and they are interior. And then you might need to look back up the rules, right? And so what do we know about consecutive interior angles as long as we have parallel lines? They are supplementary. So what we need to think about is we need to add, sorry, that should be a minus, x minus 24 plus 2x plus 42. And we need to add those up and set them equal to 180 since they are supplementary. Okay, so we've all had algebra. It might have been a little while, but we've all had algebra. So we add like terms. And then we just start solving, right? So we would subtract 18 from both sides. So we end up getting 3x equals 162. And then we'll divide by 3. So we end up getting x equals 54. Okay. Notice if I would have asked you to go ahead and find the angles, then you would have plugged that back in. Okay. Also notice my picture's not to scale. In other words, plug in 54 here and you're going to find that this is a 30-degree angle, and it doesn't really look like that. But we talked about that before. Clearly, you know, we're not all artists and our angles aren't always going to be perfect. Okay. So remember what you can say. You can just say picture, not to scale. Okay, so one relationship that you might have is that they are adding up to 180. So let's do another one. So let's draw 2 parallel lines. indicate that they're parallel by this. And then let's say this is the transversal. And then let's say that I give you this is 3x minus 35, and this is 2x plus 52. By the way, typically you're going to see these degree symbols here. Technically it would have been over here also. Alright, so let's talk about what kind of angle pairs these are. Okay, notice this is top right on this parallel line. This is top right on that parallel line. So these are corresponding angles. And what do we know about corresponding angles when the lines are parallel? They are congruent. So in other words, I just need to set these equal to each other. I don't add them up and set them equal to 180. And then I just need to solve. So I'm going to move 2x this way. Okay, that's going to give me 52 equals x minus 35. And then if I want to solve for x, I'll add 35 to both sides. So in the end, I get that x equals 87. So I definitely didn't draw this one to scale because this is going to be too big. So notice I asked you to find each angle. Okay, so this was kind of a poorly set up problem because I just made some stuff up and made up 2 equations. Okay, the ones that you'll have for homework will be a little bit better designed. Okay, but notice I didn't ask you for x in this case. I asked you to find out what the angles were. And so you would technically plug it in. Again, this is definitely not to scale, right? Because this is going to be bigger than even 180. So when you design problems, they're not always going to work out where the picture necessarily matches what you have. But notice this is 226 degrees. Okay, and the other one would be the same, but let's go ahead and check it. We know it should be the same, right? Because they are supposed to be the same as each other. Okay, so that would be the answer, but I'm going to say this. Clearly the picture is not to scale. Okay, so you can't always judge things based on the picture. And you know, I like to say this not just because I'm not that great of an artist, but it's a good idea maybe for you not to create problems where it works out like that kind of crazy number, but it's a good idea for you to get your students not so used to judging by the picture. Okay, in other words, not looking at it and saying, hey, I'm going to guesstimate that I think that's a 90-degree angle. Okay, you actually want them to have to show the work. And frankly, on state testing, they're going to need to be able to do that also. Okay, a lot of times the pictures do not match the data on the state testing. Okay, so I'm not doing this on purpose. It's just my my X picking skills wasn't that great on this problem. Okay, but it can still work out. Okay, so just remember on your homework for this, you are either going to be setting things equal to each other, as in example 4, or you might be adding things up to 180 because the only choices for our 4 angle pairs are they're congruent to each other or they are supplementary. Okay, and you just need to figure out which one's which.